Hey, it's OG Math Mosley, and today we're going to take a look at an example on how to use the 68, 95, 99, 7 rule with an example about batting averages. All right, so we're going to be looking at a normal curve and using the empirical rule, or 68, 95, 99, 7 rule, to work through an example. Yeah, so let's take a look at what we got. All right, so here is our the normal curve, 68, 95, 99, 7 rule. We're looking at the batting average example. Right, our normal curve below here models the distribution of batting average for 432 Major League Baseball players with at least 100 plate appearances in a recent season. The mean of 432 batting averages was 0.261, and the standard deviation is 0.034. The curve below is assuming that the distribution is exactly normal with mu, or mean, of 0.261 based on the mean of the averages, and sigma, or standard deviation, of 0.034. And again, they're using the standard deviation from the actual data of the 432 batting averages. Right? So now, question one. And again, so let's just look at the curve here. We have 0.261. All right? That is mu. Right? That is our mean. Right? The difference between 0.261 and 0.295 is the standard deviation of 0.034. All right, so to get from here to here, we add 0.034, and we get to 0.295. To go one standard deviation to the left, we have to subtract the standard deviation of 0.034. And so that's how we've gotten these markings along our horizontal axis here, right? So, and then this is the density curve that followed the data, right? And it happens to be normal curve, right? So this is kind of how this was created, so I wanted to make sure and specify that. So question A, what percent of the batting averages are greater than 0.329? Right, this is important. We're looking for greater than 0.329. And we want a percent. This is good. 68, 95, 99, 7 rule gives us percentages, so we're already in the right unit, so to say. So we need to find 0.329 on our graph here, which luckily it is one of our spacings of the standard deviation. It is right here. All right, 0.329. So we're essentially going to draw a line here out to our curve, and we want to know what's the proportion of our data, essentially, that's in that blue shaded area now, right? Everything to the right of 0.329, because we're looking for, again, greater than, so above 0.329. Now, our 68, 95, 99, 7 rule says that within one standard deviation, right? So if I kind of like sketch this up here, give or take, again, it is not going to be perfect, but that's okay. So again, this is 68%. If I go within these two, that is 95%, right? Leaving 5% left to the right, above 2 standard deviations and below 2 standard deviations. There's 5% left between the two, but it's split evenly. So that means there's 2.5% here and 2.5% to the left. That's useful, because that means that's our answer. Right? This represents 2.5% of the batting averages. So for part A, I'm going to ask, what percent of batting averages are greater than 0.329? Well, 2.5%. Excellent. So there we go. Now, question B. What percent of batting averages are between? And now we're going between 0.193 and 0.295. All right. So now we need to find these again. On our graph, we've got 0.193 is right here. It's good. It's one of our standard deviations. And 0.295 is right here. And it's one of our standard deviations. Once again, this is good news, right? We can use what we know. So we're going between these two. This is what I'm looking for, between here and here. Well, I get to include the 68%, and I need to know what is between here and here. But once again, we're lucky here. We know that to get from 68 to 95%, we can find that number. 95 minus 68 is 27. Half of 27, because that needs to be split evenly between these two sections, right, is 13.5. Meaning that this proportion between 0.193 and 0.227, or between -1 and -2 standard deviations, represents 13.5% of my data. Sweet. That means that the percent has to be 68% plus 13.5%. And that's going to be 68, 81, 81.5. If I can math today. 6, 7, 81.5%. So we get our solution again, just using the 68, 95, 99, 7 rule. We don't have to do any other calculations, which is super helpful. Makes it easy. And we get the solution. So there it is. All right. Once again, if you have any questions, please let me know. Otherwise, we will see you next time. Bye.